All right, Panthers. Today we're talking about proportions. So we've already gone through the module on one-step equations, and before that we did equivalent ratios. Proportions is an idea that will combine those concepts. So first let's get some note-taking done. So go to your notebooks, go to your table of contents, put down the date and the title and the page number. There we go. So for me, the date is 9/21/20. Title's proportions. I'm on page 12. Okay, so fill out your table of contents. Go to the page you're on. On that page, at the top, write down proportions. Okay, the definition for proportions is this. It's an equation showing equivalent ratios. So we've already done equivalent ratios, so without even knowing it, you've already kind of gotten your feet wet a little bit with proportions. Let me give you some examples. Let's say we've got a 3:6 ratio. You could write 3:6 like that. Now there's an infinite amount of ratios that are equivalent to 3:6. I just picked one of them randomly. 3:6 is equivalent to 6 to what? What would go there? 3:6 is equivalent to 6 to, if you said 12, you're right. Let's do another example. So let's say we have a 4:5 ratio. Okay, 4:5 ratio. So again, there's an infinite amount of equivalent ratios to 4:5. So I just picked one randomly. Let's say I put a 15 right here. What will go there? 4:5 is equivalent to what to 15? Hopefully you know the answer is 12:15. All right, so the next thing you're gonna write, let's see here. I need to erase to give myself some space. Make sure you've got this written down already. If you didn't, pause the video to write that down. But next, what I want you to write is this. In equivalent ratios like this, the cross products are always equal. Underline always, because it's not sometimes always equal. Now product means that you're going to multiply. So cross products is like this. Take this 3, multiply it by the number across from it. Take this 6, multiply it by the number across from it. So check out what happens. If you do 3 times 12, that equals 36. If you do 6 times 6, that also equals 36. The cross products are equivalent. So as long as you have equivalent ratios, the cross products are going to be equal. Let's try it in the other one we came up with down here. So multiply 4 times 15, that equals 60. Multiply 5 times 12, that also equals 60. The cross products are equivalent. So that idea is going to help us as we start to use some algebra with these proportions. All right, so make sure you've got this copy down. If you need to pause the video to get caught up, do that now. All right, so let's check this out. We just did the one where we had a 4/5, and I think I put a 15 there, and it was pretty easy to figure out that this number was going to be 12, because you could do times this by 3, times this by 3. But let's say we had 4/5, and let's say we had 9/blank. And this one's not as obvious. Some of you can figure it out, but it's not as obvious because it's not like a multiple of 4. Like 4 times 3 is 12. 12 is a multiple of 4. 9 is not a multiple of 4. So to multiply 4 to get to 9, you'd have to multiply by a decimal number or a fraction number, and that's going to be a little bit trickier to think about. So instead of doing it that way, there's a different way we could solve this problem using the cross products. Okay, so here's how we involve a little bit of algebra into these proportions. Whatever number is missing, you can put in a variable there. Oftentimes, x will be the variable that you see. So now we've got 4 to 5 is equal to 9 to x. Since we know the cross products are equal, check out what we could do. Let me change colors here. We can multiply this times this. Now you might be wondering, how can we multiply 4 times x? Really easy, you just write this. 4x, that means 4 times x. Also multiply that cross product. 5 times 9, so 5 times 9 is 45. Put these numbers across from each other like this. So we have, again, 4x is the product of 4 and x. 45 is the product of 5 times 9. Set them equal to each other because, again, we know the cross products have to be equal. So 4x equals 45. Now you've got yourself a one-step equation. So remember that you just did the module with one-step equations. You bring down the equal sign. You isolate the variables. So we're looking at this side. What's the opposite of multiply by 4? It's divide by 4. And remember, if you divide one side by 4, you have to divide the other side by 4. Cancel those out. You've got your x. Divide this. Now, if you want to use a calculator to divide that because it's not going to work out evenly, I'll let you use a calculator at this point. As long as you're showing all of this work, you can pick up a calculator now and enter it into the calculator. Or if you can multiply it by hand, you can multiply it by hand. I think I can do this mentally. I think it's going to be 11 with a remainder of 1, which means 11 and 1/4. Or if you did a calculator, I probably told you 11.25, which is equivalent to 11 and 1/4. Okay, so now we're solving proportions. What we're doing is we're finding out the missing number to make these ratios equivalent to one another, and we're using cross products, and we're using one-step equations to do that. Let's do a few more examples. All right, next one. Let's say we're missing the number over 36 that is equivalent to 24 over 260. Pardon me. Okay, so blank over 36 equals 24 over 260. The numbers are obviously a little bit bigger this time. So again, you can put a variable there. You can put an x. Sometimes you'll see like an n right there, whatever variable you want. So the way that we can find out what is that missing number, because again, it's not so obvious what to multiply or divide by, we could use the cross products. And again, if you want to have a calculator ready, you could have a calculator ready. I'm going to use a calculator in this one myself. So, what is the product of n times 260? Well, it's 260n, which means 260 times n. What is this product? Now, if you want to work that out by hand, you can. It shouldn't take you too long to do 36 times 24, but if you want to put it in your calculator, you can. So I'm going to put in 36 times 24. That equals 864. Now, even though I'm using a calculator, I'm still showing all of my work. I'm just not doing the scratch work that's done in the calculator. Now, what symbol goes between these? Remember, the cross products are always equal, so put an equal sign between them. Now we've got a one-step equation. We bring down the equal sign. We want to isolate the n. This means to multiply by 260, which means we have to do the opposite. We're going to have to divide by 260. So we'll divide this by 260, cancel those out, but that means we have to divide this by 260 as well. Now again, if you want to work that out by hand, you can. I'm going to use my calculator. I'm going to put 864 divided by 260. And again, even though I'm using a calculator for this, I'm still showing all of my work on here. Okay, so this one is a decimal 3.323. So it's a decimal that goes on for a long time in there. Let's round to the nearest hundredths place. So the hundredths place is the second one after the decimal. So if my calculator says 3.323076923, so the hundredths place goes like this. Here's the decimal, tenths, hundredths. So we're going to round it right there. Now you look at the digit after that to tell this to either go up or stay the same. So that's a 3. Is that telling this to be 3.32 or go up to 3.33? If we round to the hundredths, it's 3.32. And there we go. Now, since we rounded, n is not exactly equal to this, it's just really close. We could put this symbol in, which means about equal to. So n is about equal to 3.32, which makes sense. 24 out of 260 is a really small amount. 3.32 out of 36 is also a really small amount, and makes sense that those are equal to each other. Okay, we've got 2 more examples we're going to do. The next 2 examples are going to be in word problems. All right, here's your first word problem. Go ahead and copy this down in your notes. It says, Jack could plant 16 trees in 12 hours. If he works 30 hours, how many trees can he plant? So again, this guy Jack, he works as a landscaping dude, and he's planting trees. He could plant 16 trees in 12 hours. But if he works for 30 hours, how many trees can he plant? So pause the video to copy this down, to get it copied down in its entirety, and then after you pause the video and are ready, then we're going to talk about how to solve it. All right, so to solve this, we're going to set up a proportion, which is where one ratio is equivalent to another ratio. All right, so we're comparing 2 different things in here. We're comparing how many trees, but we're also comparing how many hours. So you could either put trees over hours, or you could put hours over trees. But whatever way you pick, you got to be consistent. If you're doing trees over hours here, it's got to be trees over hours here. But if you're doing hours over trees, that's fine. Just make sure the other one is hours over trees. Since it says 16 trees, I'm going to put that first at 16 trees. I'm going to put that with 12 hours. All right, so I know one of the numbers over here, but one of them I'm missing. The number I know over here is 30. Now, do you think that should go on the top with the trees or on the bottom with the hours? That's about working for 30 hours, so that should go on the bottom. So the question is, how many trees? We're trying to figure that out right there. 16 trees in 12 hours. How many trees for 30 hours? So again, you can pick a variable to put right there. I'll put x. Now, just like we did in the last two that weren't word problems, we're going to solve this word problem the same way. We're going to get the cross products. So to show my work, I'm now going to erase this, but make sure you already have the word problem written in your notes. Okay, so now that we changed the word problem into a proportion, remember what we could do is get the cross products. We could do 16 times 30. I think I could do that mentally. 54, 540. All right, and that's equivalent to the other cross product. So what do you write for 12 times x? 12x. So 540 equals 12x. If you wanted to do 16 times 30 in the calculator, I'll let you do that as long as you show your work like this. Okay, bring down the equals. Now this time we're looking at this side because this side has the variable. We're going to isolate the variable. We want to get rid of the 12. Since that means multiply by 12, we have to use the inverse operation. We have to divide by 12 and then cancel those out. But if we divide the right side by 12, we have to divide the left side by 12. If you want to do that by hand, you can. If you want to put it in the calculator, I'll let you do that. 540 divided by 12 equals 45. Now thinking back to the word problem, let's label that. So if you go back and read the word problem, what are we solving? 45 what? And I believe it was 40, well, actually look down here. Yeah, for sure it was 45 trees. It was 45 trees that he could plant in 30 hours of work. And that's equivalent to planting 16 trees in 12 hours of work. Let's do one more word problem. All right, here's the last example problem for these notes. Again, it's a word problem. It says, Lisa walked 8 miles in 2.5 hours. How long will it take her to walk 10 miles? So since to walk 2.5 miles, for 2.5 hours, she could walk 8 miles. This time she wants to walk 10 miles, which is a little bit longer. So it should be a little bit longer than 2.5 hours. It's not twice as far, so it's not going to be twice as long as 2.5 hours, but it's a little farther. It should be a little bit longer than 2.5 hours. But to get the actual amount of time, we could solve this by making a proportion. Because a proportion is good anytime you're talking about ratios. And ratios are anytime you're talking about comparing two quantities. In this case, we're comparing the quantity of miles with the quantity of hours. Now again, you could put miles over hours or hours over miles as long as you're consistent on the other side. Since if it were a unit rate, I would probably do like miles per hour. I think I'm going to put the miles first and the hours second, like this. Okay, so if I put 8 miles over 2.5 hours, what should go on this side? One of those on that side is going to be a variable. Okay, the number that I know that goes over here is the 10. Should the 10 go on top or on the bottom? Well, I've got miles for my numerator, so the 10 is miles. That should go up there. This could be hours. In fact, if you want to call it variable h to represent hours, you could do that. Okay, so again, you read the information from the word problem. You compare it as a ratio where it's something over something equals something over something. Miles over hours equals miles over hours. I'm going to erase this up here. Make sure you've got yours copied down. And to solve this, we could use cross products. By the way, if she wanted to go 16 miles instead of 10 miles, I wouldn't even need cross products, because if you wanted to change 8 miles to 16 miles, you would just double it. So you would just double the hours and you'd be done. But because 10 is not a multiple of 8, it's not quite that easy for this one. So let's multiply this times this. That's 8h. And let's multiply 2.5 times 10. Now, there's a shortcut for multiplying a decimal number by 10. But if you didn't know that shortcut, you could put it in the calculator or do it by hand. But the shortcut is anytime you multiply a decimal number by 10, the decimal goes one spot to the right. So instead of 2.5, I know that's going to be 25. Okay, so we have 8h for one of the cross products, 25 for the other cross products. What symbol goes between them? The answer is an equal sign goes between them. Okay, let's bring the equal sign down. Let's isolate the h. How do we get rid of the 8? Well, since this is multiplied by 8, we divide by 8, and we divide the other side by 8 as well. If you don't know what 25 divided by 8 is, you can either work it out by hand, or you can put it in a calculator. I know that it equals 4 with the remainder, I'm sorry, it doesn't equal 4. It equals 3 with a remainder of 1. Okay, so 3 remainder of 1, which is 3 1/8, which if you did it in the calculator is 3.125. Now, 3.125 what? Remember, we're trying to figure out how many hours, so it's 3.125 hours. And that's how long it would take Lisa to walk 10 miles. So again, it takes 2.5 hours to go 8 miles, but if you want to go a little farther to 10 miles, it's going to take a little bit longer than 3 hours to do that. Okay, so that's equivalent ratios, which are called proportions, and that's how to cross multiply and your proportions to set up algebraic equations and then solve the algebraic equations to find out the missing quantity, which we're making the variable, like x or n or h or whatever the variable is. All right, very good. We'll see you next time, Panthers. Keep up the good work.